So now for the distribution of the sample proportion, that's going to introduce now a new variable, this p hat, that's going to be equal to the number from the sample with a certain characteristic divided by the sample size. And we could do various calculations involving that, just as we did with the sample mean. So, for example, if the Harris poll conducted a survey of 1,200 adult Americans who vacationed during the summer and asked whether the individuals planned to work while on summer vacation, of those surveyed, 552 indicated that they planned to work while on summer vacation. And we want to calculate the sample proportion on individuals who plan to work while on summer vacation. So the characteristic of working while on summer vacation, 552 said they would, out of a total of 1,200. And this is going to be our sample proportion, or p hat. And that number will be equal to 0.46. So the sample proportion in that case is about 40, well, I shouldn't say about, is 46%. Now, as we have previously seen with the sampling distribution of the sample mean, p hat could also be given a probability distribution. Its shape is going to be approximately normal, but unlike what we saw with the sampling distribution of the sample mean, the way that we could determine that the sample proportion distribution is going to be approximately normal is provided that we have the sample size times the population proportion times 1 minus the population proportion. That product is at least 10. The mean of the sampling distribution is going to be equal to the population proportion. The spread is going to be equal to the square root now of the population proportion times 1 minus the population proportion divided by the sample size. And in order for us to have independence, we need the sample size being less than or equal to 5% of the population size, although for a lot of these questions, unfortunately, it has to be an assumption, although if you are given the population size, you could certainly verify that assumption. So, for a few examples involving this, we have, according to a study conducted in one city, 32% of adults in the city have credit card debts of more than $2,000. A simple random sample of 450 adults is obtained from the city. We want to describe the sampling distribution of our sample proportion of adults who have credit card debts of more than $2,000. So to verify that this is going to be approximately normal, we're going to do 450 times the 32%, so 0.32, times 1 minus 0.32, that'll be 0.68. And for this to be approximately normal, we want that value to be at least 10. And in this case, we get a value well greater than 10, 97.92. So because of that result, this is going to now be approximately normal. So the mean of our sampling distribution will be just equal to the population proportion, or 0.32. The standard deviation is going to be equal to the square root of 0.32 times 0.68 divided by 450. And that is going to give us a value of, let's see, of 0.022. About for that standard deviation. Now for our next example, according to the National Center for Health Statistics, 15% of all Americans have trouble hearing. In a simple random sample of 120 Americans, we want the probability that at most 12% have trouble hearing. So now we could verify the usage of the normal model as 120 times 0.15 times 0.85. And again, we want that number to be at least 10 in order for us to use the normal model. And this value gives us a value of 15.3. So 15.3. That's at most 10. We could use that a normal model. So now before we do this particular example, we do need the mean of our sampling distribution. That's going to be equal to 0.15. And the standard deviation is going to be that messy calculation of 0.15 times 0.85 divided by 120. And we want to find the square root of whatever that value is. So throwing that into a calculator very quickly is going to give us a value of 0.0326. So for this, we want the probability of p hat at most 12%. And giving a very rough sketch of this normal distribution right here, we call 0.15 right here, 0.12 about here, and since we want that to be at most, we'll talk about the area then to the left of that in the normal distribution. So then throwing that into StatCrunch underneath. Now again, since it's approximately normal, stat calculators normal. We're using a mean of 0.15. Standard deviation of 0.0326. At most 12%. That's going to give us a value of 0.1787 in the area to the left of that value. Now, to suppose that random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. Now, again, this uses the same values as before, so we're not going to need to change the mean or standard deviation, but now we could calculate the sample proportion. Okay, so the sample proportion for this is going to be 26 over 120. And we need that decimal amount. So 26 out of 120 is about 0.217. And we want to find the probability involving p hat here. So let me just quickly draw again a rough sketch of this. So using that same mean of 0.15, 0.217 I would say is about here-ish. So trying to determine what we want to say about that would be about whether or not it's unusual in that regards. So we want to find the probability that p hat is greater than that value of 0.217. So we want to change this to greater than, and this to 0.217, which will give us a value of 0.0199, which, if we use 5% as a level of significance, this would indeed be considered unusual. So now our next example. Smith is a weld inspector at a shipyard. He knows from keeping track of good and substandard welds for an afternoon shift, 5% of all welds done will be substandard. So the population proportion is 0.05. If Smith checks 300 of the 7,500 welds, so now we have a population of 7,500, sample size of 300. What's the probability he'll find less than 20 substandard welds? So x is 20. So for this, the mean is going to be equal to that 0.05. And then the standard deviation, I'll just do over here, will be equal to the square root of 0.05 times 0.95 divided by 300. And we want the square root of whatever that value is. So very quickly throwing that into a calculator, we'll get ourselves a value of 0.0126. So for something like that, we are going to do then, and we need p hat. So p hat is going to be equal to 20 over 300. And then that value will be about 0.067. So the probability that p hat then, probability that p hat is less than 0.067. We'll have fun what that's equal to. And again, just to give a very rough sketch of what the area is going to look like, if our population proportion of 0.05 is right here, 0.067 would be about over here-ish. We want the area over here to the right. Sorry, not to the right. Talk about the area less than that. So that'll be then to the left over here. So tossing these numbers into StatCrunch. So 0.05 for the mean, 0.0126 for the standard deviation. We want this to be less than 0.067. Throwing that into StatCrunch, we'll get a value of 0.9114. And then from that, we want to know if it's unusual to find 30 or more substandard worlds. So for something like that, we want to recalculate then p hat to be equal to 30 over 300, which would be about 10% for that. That means then that the probability then of p hat being greater than that 10%. And that rough sketch is going to be about, the mean is right here, above 10% would be the area to the right of this value here. And that value, once we plug that into StatCrunch on here, is going to be equal to this lovely low value of 0.00004. And then for the next example, with exit polling is a popular technique to determine the outcome of an election prior to results being tallied. We want to suppose a referendum to increase funding for education is on the ballot in a large town of 100,000 voters. An exit poll of 200 voters found that 92 voted in favor of the referendum. We want to know how likely are the results of the sample if the population proportion of voters in the town in favor of the referendum is exactly 51%. So for that, we want to determine sample proportions then going to be equal to 92 over 200, which will be 0.46. Then the mean of this sampling distribution is going to be equal to 0.51, and the standard deviation will be the square root of 0.51 times 0.49 over 200. And that value is going to be, why don't you throw that into a calculator, 0.035. So now we want the probability then of p hat now. Since we want to find how likely is that. So we, due to the fact that the p hat is indeed less than 0.51, we want the probability of p hat being less than 0.46. And we could see that in, let me just expand this out to do this picture. A very rough sketch of this, of 0.51 here, and then 0.46 will be over here. And we want to determine the area to the left of that. So, throwing that into StatCrunch on here, and we want to determine this to be less than 0.46. Throwing that into StatCrunch will give us a value of 0.0766. Thank you.